Welcome back, everybody, to Psych290 Research Methods in Psychology. There were a couple of things in Chapter 8 that I didn't get to that I want to talk about, so I'll talk about those in this particular part of the lecture. This would be Part 3 of Chapter 8. So we've talked about the idea of interactions. There were a couple of examples of interactions that were in the text also that I want to step through, or in the lectures. Okay, the first one was this study of imagery as one independent variable, or the instructions given to participants for a word list study, for a memory experiment. So, if we were running this as a one-factor experiment, we would want to know whether imagery is actually better for encoding words than just rote learning, that is, repeating the word over and over to yourself. So that would be how we would do it, and that's actually very similar to the generation effect lab that we did. Okay, we had some sort of elaboration that was done versus no elaboration. So in this situation where you have imagery versus no imagery, or rote learning, that'd be one independent variable with two levels. But in the example given in the notes, we add a second independent variable of presentation rate. How long is each word presented in this word list? So that could be either 2 seconds for each word, or 4 seconds for each word. Okay, so those are the two levels of the presentation rate independent variable. So hopefully at this point you would know that this is a 2 by 2, and assuming that each person is going to be randomly assigned into one of these 4 different groups, it would be totally between. Okay, so it would be a 2 by 2 between subject design. Okay, all right, so far so good. So why would we want to do that? Okay, so, and why might we hypothesize an interaction going on here? Okay, so let's do the simple things first. Okay, we would assume, or at least predict or hypothesize, that there would be a main effect of presentation rate. You have more time to learn the word, you're going to do better. So we would hypothesize that 4 seconds per word is going to be better than 2 seconds per word. So we hypothesize a main effect of presentation rate. Okay, we would also predict, given what we know about learning, that the more you elaborate on the word, the better encoding is going to be. So we're going to hypothesize that imagery instructions is going to be better than the rote instructions. Okay, but now here's the the interesting thing, right? In terms of interaction. Okay, why would you think, or why would you hypothesize an interaction? Okay, basically the idea is that if you have just 2 seconds per word, you may not be able to do the imagery instructions that well. Okay, but if you have 4 seconds per word, then you're actually going to be able to do it much better. You have twice as long to implement this effective strategy. Okay, so in this particular case, we would hypothesize an interaction that basically would look like there's certainly a benefit to imagery over rote at 2 seconds per word, but that difference, that improvement, would actually get bigger at 4 seconds per word. Okay, so essentially that's what the data, at least the data in this PowerPoint slide, does show. That is, there is an improvement of imagery over rote at 2 seconds, but there's a greater difference. There's a greater improvement at 4 seconds per word for imagery. Okay, so hopefully that explains one type of interaction. Okay, another interaction. Dun, 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 dun. My prop for the day is a pot sticker box. Okay, yay! All right, so why am I showing you a pot sticker box? Essentially, the ideas for research can come from anywhere. All right, so we were, we actually make our own dumplings. I had a housemate from Taiwan when I was in college, and he taught us how to make Chinese pot stickers. Okay, so we actually still make our own. Okay, and we actually prefer our homemade ones, okay, to store-bought ones like the one that I just showed you. Okay, and there's different ways that you can prepare pot stickers. You can either boil them. Actually, there's more than 2, but the 2 that we use are either we boil them or we pan fry them. And as it turns out, we were thinking about this the other day, we definitely like our homemade ones better than the store-bought ones when they're boiled. Okay, but pan fried, we like the pan-fried ones, you know, a little bit better than they are when they are boiled. So that difference between the two actually gets smaller during when we have them pan-fried. So essentially, this is the exact opposite of what I was just telling with the curve, the way the curves look with this interaction. Okay, so we could put this to the test, and you might say, well, why would we want to do this? Well, you know, people that put Gouda might want to know that. Okay, you know, do people prefer them boiled or pan-fried? Okay, so you know, we can actually put this to the test, a taste test, if you will, and see if that is the case. You know, is it the case that there's a difference between, you know, homemade pot stickers and the store-bought ones, and that benefit would certainly be the case when they're boiled, but maybe that improvement or that difference isn't quite as great, okay, when you have them pan-fried. Okay, so, you know, why did I mention this? Just again to make you start thinking, you know, ideas for research are anywhere. Okay, way back in chapter 2 we talked about this. You know, just keep your eyes open, keep your mind open, and you never know where, you know, an idea for research may come from. You know, will I do this? Probably not. Okay, but you know, if you're, you know, but that's the idea, right? Okay, you know, you never know when you're going to, you know, find something that you may want to pursue and really act on in terms of the research. Okay, all right. The other thing that I want to mention in terms of this chapter is, again, when you're, I didn't mention this before, if you're graphing the results of a 2x2 or any two-factor experiment, you plot it in the sense that you have one independent variable on the x-axis, and that's going to be represented on the x-axis. The y-axis is always going to be the dependent variable. Okay, but so how do you represent that second independent variable? You do what is known as a curve parameter. That is, different lines on the graph are going to represent the other independent variable. All right. So if we go back to the original example that I gave, you know, just a second ago about, you know, word recall and the two independent. So word recall is the dependent variable. The two independent variables are presentation rate and learning instructions, imagery versus rote. Okay. What we can do is put presentation rate on the x-axis. 2 seconds per word versus 4 seconds per word. Okay, and again, you know, number of words recalled, the number of words recalled are going to go on the y-axis. So then you take one line for each of the other independent variable. So this particular case would be imagery. So you plot, you know, using one different symbol, you plot the 2 seconds per word, and use like a circle for that for the rote instructions. Then you use that same circle for the rote instructions on 4 seconds per word. Then you draw a line between those two. Then you do the same thing for the imagery instructions. You know, what was the mean for imagery instructions at 2 seconds per word? Okay, you know, draw a filled in square. And for imagery instructions at 4 seconds per word, you use a filled in square. Connect those lines. So basically what you're going to do is have, you know, 2 lines on this graph when you have a 2x2. Again, if it's a 2x3, you just have one more, you know, data point. So you would have 3 different levels on the x-axis, for example. Okay? All right, so that being said, the other thing that, you know, again, is this is, again, a rule of thumb. Okay? It's not, you know, guaranteed. But one way to know whether or not, or suspect, let me phrase it that way, that there is an interaction is if the lines deviate from parallelism. If those 2 lines aren't parallel, you can suspect that there might be an interaction. Again, you went through statistics, Psy290, for a reason, because the statistics will actually tell you whether or not there's an interaction or not. Okay? But, you know, if you just look at the graph, it will at least give you a sense of if you might suspect an interaction. All right, and there's 2 different types of interaction. Okay, in this particular case, well, in any case, you have 2 different types of interaction. What's called exponential interactions. That is, the lines do not cross over. Basically, what I was just, you know, phrasing in both of those examples I just gave you for the imagery versus rote instructions and presentation rate. Presentation rate difference is going to be smaller for 2 seconds per word between imagery and rote, but that difference gets bigger at 4 seconds per word. So that's where that deviation from parallelism will come from. Smaller at 2 seconds per word, and then gets bigger at 4 seconds per word. All right. So the other type of interaction is what's called a crossover interaction, or also known as a antagonistic interaction. So basically, that's what you would have for some situations, like when you have any study about context-dependent memory, for example. Okay, so if you remember from cognition classes, context-dependent memory simply means that there has to be a match between where you the context in which you encode a word and the context where you retrieve the word. So, for example, if you are one of the classic examples was if you learn something underwater versus at poolside. Yes, there's a way to test your recall even if you're underwater. Okay? So, what happens best is that recall is going to be best is if you learn the word underwater and then you retrieve the word underwater. Okay. Also very good is if you learn the word at poolside and if you're tested at poolside. But any of those changes, any of those mismatches actually leads to poor performance. So if you learn the word on poolside but retrieve the words underwater, that's not as good. Okay. Or if you learn the word on poolside and you try to retrieve the words underwater, that's not as good either. So any of these mismatches. So if you think about that and you draw out that type of plot, the lines will actually cross over. Again, just because they cross over doesn't necessarily mean that there's going to be an interaction. That's why we do the statistics. Okay? All right. So those are the two major types of interaction. So, okay. All right. And then, again, talking about statistics in a two-way analysis of variance, you have one F value for the main effect of one independent variable. You have one F value for the main effect of the second independent variable, and you have an F value for the interaction. Okay. Again, I think you've got a handle on that based on the information that was given in the Psych Files video. Okay. But what I didn't return to is the idea of a three-way analysis of variance. Okay, so now you have three independent variables. Okay, so the bonus question that was involved there is how many F values do you have if you have three independent variables? If you have a 2 by 2 by 2, for example, or 2 by 2 by 3. Okay, so how many F values do you have? Okay, well, for each of the individual independent variables, you will have a main effect, an F value for the main effect. So that's 3 right off the bat. One for each of the main effects. And because you have a two-way interaction for each pair of independent variables, okay, you will have 3 more F values. One for the interaction of, independent variable 1 and 2, 1 and 3, and 2 and 3. Okay, so now there's 6 F values. What else do you have? You have what's known as a three-way interaction. There is the same idea is that, something could occur differently over the levels of each of those 3 independent variables. So there is an F value also for if there is a three-way interaction of all 3 of those independent variables. All right. So the answer to that bonus question is actually 7. Okay, there are 7 F values when you have an analysis of variance for any three-way study, okay, any three-way design. Alrighty? Okay, so that hopefully catches us up with the end of Chapter 8. I'm going to, again, post another video about correlation, probably, maybe not today, but probably tomorrow morning, and then, that will pretty much catch us up to, all the information that I am requiring you to know for this particular course. All right, so take care, everybody. Stay safe, stay well, and we'll talk to you and hopefully see you not too distant future. Okay, take care. Bye.